Yeah, this one is working. Yeah. Okay, good. Yeah. Yeah. Sure. Yeah. Okay, can you hear me? Yes? Bangalore, can you hear me? Yeah? Pune, can you hear me? Okay. All right. Okay. Good. All right. So, how was the fish? How was the fish? Did you get fish? Okay, I'm a vegetarian. I don't eat. So I'm just asking. Okay. All right. So, let's go with the other applications. We'll continue. Yeah. All right. So this you already saw. Okay. Um, you can also use brain signals. All right. Please settle down. I'm still hearing some voices. So you can use brain signals to control, and in this we have used only EEG signals uh, by what is called the P300 wave. Okay, and we'll go into some detail on what is this P300 wave, right? Right, positive peak that is coming at around 300 milliseconds after you ask for a stimulus. Okay, so that's called P300. Okay, there is a peak after 300 milliseconds after you put a stimulus. Okay, all right, that's called P300 evoked potentials, right? So by using that, we're controlling this up, down, left, right movements of this robotic limb. Okay, so you could use such brain signals to control the robots as well. Actually, that is the final goal, right? Hopefully, at some point we'll be able to control the robots purely with our thought, right? Right? By using as safe as possible technologies, non-invasive technologies, etc. Right? Okay. All right. And then this is new to our lab. This technology and this theme of research is new to our lab. We're trying to develop an integrated wearable system that can help with SUD. What is SUD? Some everybody's seeing and reading, huh? Okay, so that was totally intentional because after lunch, if I ask something, you're like, yes, sir. You're like that, right? But at least you are reading, which means your eyes are open and your mind is working. Okay, good. Okay, so this is a new theme of research that added to our lab, and the reason it got added was we were working on how we can use emotion detection in robots, right? And so slowly we got into this area where you can actually read somebody's emotions, right? So Bangalore group out there, civil engineers, yeah. So this type of technologies are used for construction workers because believe it or not, construction workers are the workers that are in high risk jobs, right? Because high risk meaning not that they will lose their job, they will lose themselves, they will die, right? Very prone to accidents, etc. So even if they are feeling a little bit drowsy or if they are under heavy sun all day, right? And if their head is spinning a little bit, they fall from 30 floor height, right? So this type of technologies are used a lot for construction workers. Okay, so so this is a question for you guys. Okay, um, were you ever stressed out in your life? If yes, raise your hands. If you're stressed a lot, raise both hands. Everybody's doing that, is it? Okay. And some of them they're not raising their hands, so which means you have purified your existence, is it? Huh? And you're the supreme, huh? Okay. So when you're stressed out, what do you do? What are your strategies? What are your coping strategies when you're stressed out? Raise your hand if you want to give an answer. When you're stressed out, what ma'am, physiotherapist, please. Yeah. Some eat sweets, eat food. Eat food. Yes, yeah. Yeah, you are angry with somebody, you start eating. That's a good strategy. Yeah. So this was October last year. October last year, I gave a talk at Stanford, and the professor who invited me for the talk there, he is shorter than me, and he's double my weight. And so I asked students, and everybody was sitting there, and I asked him, "What are your coping strategies?" And everybody said, except food, everybody said everything. And the professor was like, and I prompted, okay, for some it's food, and then the professor was, I didn't want to say it. Okay, so for some it's food, right? Okay, what else? Sweets, particularly sweet. Particularly sweet. Not even chips won't cut it for you. You want sweets. Okay, good. What else? Huh? Songs, music. Very good. Yes. Music for some people, right? Sit in a calm place, like a temple, like mountains. Sit in a calm place. Go for a walk. Go for a walk. Huh? Who said sleep? Please raise your hands. Please turn the camera towards them and make sure that they don't sleep. That is the batch we are going to focus on for the rest of the session. Okay, but sleep is a good. But did you guys think, if sometimes if you're really nervous, stressed out, sometimes you cannot even sleep, right? You're just lying down there, and your mom and dad are yelling in the background. You can't even sleep, right? Okay, huh? Sometimes yeah, yeah, yes, yeah. When when the anger rises, the temperatures go up, and to cool down, sometimes you cry. Yes, yeah, that happens too. Yeah. Okay, what else? Huh? Meditation, very good. Yes, yeah. Meditation. Yeah, what did you say? Is it? Sitting in a calm place, meditation. Yeah. Blasting somebody, shouting. My camera, Kumar, please. Please make sure, ma'am. After my session, Karthik will begin. You can completely open up. Okay. Okay. All right. So I heard music, sleep, food, walk, meditation, sitting in a calm place, music. Anything else? Yeah. We use that to induce stress in people. We use that exact experiment to induce stress in people. You use that to cope stress. सही सुपरमैन है भाई आप हाँ? Correct. Right. So I've heard that too. So people exercise. People exercise. Yeah. Any other? Any other? Watching a movie? Watching a movie? Yeah. Yeah. Watching comedy? Yeah. Ah, yes. To the you said to the mother. Huh? What about fathers? Huh? Okay. Sometimes for daughters, aren't fathers close friends also? Mothers seem to be strict and okay, all right. Okay, yeah, so that too, right? So opening up, right? Opening up, sharing. Sometimes, and then the other person says, "Yeah, I have the same exam problem." Then you feel happy, right? The misery loves company, right? So you're like, yeah. Oh, you have that problem. I have that problem. Okay. You have power cut. I also have, then the stress goes down, something like that, right? Okay, that's good. What else? Yeah, so these are very, very healthy, almost healthy strategies, right? Go for all, except the sweets part, but we'll excuse that for now, right? These are all very healthy strategies. But for some people, it is drugs, right? And so when we started this research, I thought this was a rich country problem, okay? Because you have to have access to those drugs, right? So I thought this was a rich country problem. But then when I made this presentation in Manipal, then they told me that we have drugs problem here, right? So when you have easy access to money, right, right. So then suddenly you start getting access to the drugs, right? So the problem with this drugs is they cause irreversible damage to the brain, right? So as soon as you start consuming these drugs, they start eating parts of the brain, and this is irreversible, right? This is irreversible damage. And so so when we started working on this topic in the US, when we did some initial surveys and all, what we found was that the rich have access to it, right? Makes sense because they're the ones that are buying. The poor have access to it because they are the suppliers. They have access to it. So the rich have access to it, the poor have access to it. Do you think the middle won't have access to it? They will, right? So the thing just permeates. So everyone has access to it. High school students have access to it. Can you imagine, right? Right? So you're all responsible professionals. You've come this far. Can you imagine going back 10 years or 5 years and you're doing drugs? Suddenly your life goes in a different direction, right? Right? So it not only affects the person who is consuming drugs, but it shatters the families, right? You know, to lose their child who has grown up. For parents, it's such a pain that we cannot even explain, right? Right? So, um, so we wanted to develop technologies for this, and again, by using wearable sensors, how many of you wear smartwatches? I lost mine in Bangalore. How many of you wear smartwatches? Yeah. What type? What type? What type do you wear? That's not a smartwatch, right? Okay. What do you wear? Yeah. Okay. Okay. All right. Any other examples? Yeah. Okay. It's a Fitbit. Yeah. Yeah. So are the newer versions of Fitbits, they can measure stress, right? So the smartwatches can tell just by looking at your skin temperature, sweating, right? So by using these parameters, these Fitbits, they can tell if you're stressed out or not, right? Yeah. So so by using wearables and by using clinical grade wearables, and these are not like Fitbits, but these are not commercial devices. These are some serious clinical devices. By using these, you can measure stress. And why am I talking about stress for so long is stress is the trigger. Stress is the key trigger for substance abuse. Okay? Stress is the trigger for substance abuse. Stress comes first, and then once you're under stress, you're looking for ways to get out of the stress, and then you take substance. That's how it starts, and that's how it destroys. Okay? So stress is the trigger. So if we have a device that can detect stress and then suppress stress, right? Somehow you have to detect stress and you have to suppress stress. When you're able to do this, you can manage those symptoms and hopefully we can avoid a trip to drugs. So that is the purpose of this device. So we're trying to measure stress using electrodermal activity, which is like skin temperature and all that, and EEG. What is EEG? Yeah, just making sure that you're not sleeping. Yeah, that's why I asked. You all know electroencephalography. Okay? EEG, EDA, and there's something else called EMA. Okay, write that down. EMA. Okay, what is EMA? Anybody? What is EMA? EMA stands for Ecological Momentary Assessment Data. Okay, um, activities, Ecological Momentary Assessment Activity or data, EMA. So what this tells us is, how many of you have smartphones? All of you? How many of you don't have smartphones? How many of you don't have a smartphone? All of you have smartphones, right? Right? So we are this upgraded generation, right? Right? If you don't have a smartphone, I wanted to clap for you because you're more peaceful, isn't it? On the smartphone, there are numerous sensors, right, that are tracking your location, tracking the text you type, right? Right? And what else can you get from those from cell phone? Location. We already said that. Direction, like which direction you're going. Okay, 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 okay. I don't know how that would help me in stress, but I okay, I get it. Okay. Screen time. Very good. Very, very good. Yes, screen time. So there are these de-identified sensors. So they don't have to reveal your name, but we can access that data, right? Because the data privacy is important, right? You don't want somebody looking at your phone, right? Right? I have a lot of personal information. I don't want somebody to be watching over me when I'm looking at the phone, right? Right? Um, so, but you can get a lot of information. For example, what you're typing. Yeah. Are you typing more sad words? I'm depressed. I'm sad. I'm bored. I'm sleepy. Okay. The other side is I'm happy, I'm excited, I'm ready to take challenges, ready, happy. So they're keywords, right? Keywords, positive keywords, negative, you can get access to these. This is called Aware Framework, AWARE. This is free. You can actually install this app on a phone that you're testing, and this will give you all this data to you free. Okay. This is called Aware Framework, AWARE. Okay. So you can access this. It's a free app. Huh? So by using this type of information, so you can also get information about how fast you're typing or how slow you're typing. That information is also important, right? Sometimes when you're stressed, you get nervous and you're typing, right? And sometimes when you're stressed, you get nervous and you're making more mistakes when you're typing. All this information you could use to assess somebody's mental state. Okay. And you can pair to that, you can pair brain signals, right? EEG and EDA, neural activity as well. Yeah. Okay. So you could use all these variables to assess somebody's mental state. Okay. All right. So if you yeah. Huh? Where are we collecting the EDA? So the initial design, what you're looking at is a headband for the EEG, and from behind the ear, there's a seat where you can record EDA. That's right. That is right. But okay, so good question. When you're making a device, when you want to put your shirt on, right? You don't put half sleeves and then you don't attach sleeves and then you don't do that, right? When you put on a jacket, one, right? So when you are wearing a wearable device, when Fitbit, for example, right? You put it on once, right? That's it, right? You don't do, okay, let's put it, and then here is the second part, and here is the third. You don't do that. That's why, right? So you have to put the product together. And actually, right now, the designs that we're working on is in-ear EEG. It's like a ear pod. That's it. Yeah, good question though. Yes. Um, so this actually goes back to Indian knowledge systems, Ayurveda. So they have very, very clear distinction between mind and intelligence. Okay, mind, which is so I'll come to that, but mind caters to your senses. Okay, so see an ice cream, you want to eat it. Okay, mind will say go for it. You see a movie poster, yeah, or you want to watch a movie, and the mind will say, go for it, okay? If you are a diabetic, you see an ice cream, you want it, mind will say, go for it, okay? So that is mind, okay? And then there is intelligence. And then that intelligence tells you what is good, what is bad. Intelligence will tell the diabetic, don't eat ice cream, that is sugars. That is intelligence, okay? That intelligence, okay, is executive decision making function that is in your brain somewhere, okay? And that is prefrontal cortex. Prefrontal cortex. That's kind of actually frontal is the difference between us and animals, okay? our frontal and prefrontal is very evolved when compared to animals. Okay, we have that executive decision-making capabilities to tell what is right, what is wrong for us. Okay, and then is mind. Okay, and that mind is right behind your eyes. Okay, and that's called orbitofrontal cortex. Okay, and that is the mind that tells, okay, you want ice cream? Okay, yes, you can go for it. Okay, so that is mind. Okay, so in this device, what we're trying to do is to inhibit, okay, or suppress mind, right, and activate or strengthen prefrontal cortex. Okay, so we're giving more power to the executive function and we're weakening the mind. So how can we do that? We do that by neurofeedback. Okay, so we'll go into some details towards the last lecture topics, but overall, that is what this device is trying to do. Make sense? Yes? Right? Empowering the mind and suppressing the, empowering the prefrontal cortex executive decision making, right? Empowering intelligence and suppressing the mind. Yeah, that's what we're trying to do in this device. Okay. And MPRC is Maryland Psychiatric Research Center. We work very, very closely with them. They're like 15 minutes from our campus. And they're the world's best in schizophrenia studies. Okay. All right. And treatment. Mm. Yeah, so this was one question that I wanted to share with you as well as ask you guys, okay? This orbitofrontal cortex is located right behind your eyes, okay? Yeah? Why is that important? Why is that significant? Huh? Emotions. Emotions, okay, okay. Right, right. And this side, somebody, you said something? Capturing the image, seeing, right? So 90% of the things that you learn in life are solely by vision. 90% of the things that you learn in life are solely by vision. So vision is such an important skill. Okay, if you for blind, for example, if you take away that, and if you look at their brains, you will see that there are compensatory mechanisms. They see by touch. They're still seeing by touch. Okay? So 90% of the things that we learn is by vision. We see and we learn. Okay, that is why that becomes so important. Okay, and then so a controlled mind is your friend. Okay, so mind could be your friend, but if it is controlled. Okay? Orbitofrontal cortex, it's not an unnecessary part in the brain. It's a good part that collects your senses, integrates that information, and passes that to prefrontal cortex. If it's not strong enough, do not say what is good, what is bad for you. Okay, so no, visual is in the back, right? Visual is in the back. This is frontal. Okay. And so this is our device that that we're building. And so pay attention to the screen. So here's the individual with STD, and here is our device. It's called NUMA, and it measures these activities: EMA, EEG, EDA, and it uses machine learning and AI algorithms, and it is multimodal, right? And I saw some of the students. Yeah, you were talking, yeah. So using multimodal data to estimate human emotions and recognition, right? So so the first thing we do is to measure stress, and we classify that into mild, moderate, and severe levels. If it is mild, we offer what is called CBT. Does anybody know what is CBT? CBT. Okay, write that down. Write that down. Okay. CBT stands for cognitive behavioral therapy. Okay. So CBT stands for cognitive behavioral therapy. And it is very much like talking to a friend. talking to an expert, right? So you said that, right? You open up to somebody. It is like that, okay? So traditionally, this was being done by therapists and counselors, right? Somebody's under stress, okay? You see a counselor and they talk to you, they process, etc., right? But in the recent times, especially during COVID, okay, a lot of these apps came up that are that offer cognitive behavioral therapy. So they just ask questions, okay? How are you? How are you feeling? Are you stressed? Okay? Um, talk to me. That's it. Tell me what you're going through. It's very, very simple questions. And you will realize, right? It's just like talking to your mom, right? So you will realize that if you know that there is somebody who wants to know how you are, who wants to care for you, that itself gets the stress levels down. Okay. For mild cases, this works. Okay. For mild cases, this works. Okay. CBT. Yeah. Um, and so the app talks to you. Okay. How are you feeling? You know, as soon as it detects stress levels going up, how are you feeling? How is it going? Okay. Have you had lunch? Which is very, very basic questions, but it helps. Okay. That's CBT. Okay. But again, you know, it's, I'm giving you examples of simple questions, but CBT has a clinical grade as well. Right? There's a like a professional questionnaire that we could use. Okay, and then the next one is neurofeedback. Okay, so you play some kind of games. Okay, this is already this is nothing new. This is at least 40-year-old. Okay, or at least 30-year-old. This has been used for children with ADHD. Okay, ADHD. Okay, that's another thing. How many of you know ADHD? Yeah, okay, a lot of hands. Write that down as well, right? Those of you who have never heard of it. ADHD, right? Attention deficit hyper disorder, right? ADHD, yeah? So ADHD, for them, this has been used for a long, long time, okay? Neurofeedback using EEG. They play video games and they're trying to give neurofeedback. They give penalty, reward, and you can slowly stimulate certain parts of the brain, give you more attention, etc. Okay, and then the last one for severe cases. For severe cases, it will be neurostimulation. Okay, so we'll be stimulating prefrontal cortex in an excitatory way, not inhibitory, right? Excitatory way. So that way you are empowering, right? So we were just talking during the break. If somebody has less electrical activity in prefrontal cortex, it means that their intelligence is weak, right? So then you stimulate, then you empower it, right? So you're generating more electrical activity. That way it gets the cortex activated, and then it'll help you in making decisions. Yeah. All right. So that is neurostimulation. And then finally, you need some type of e-report generated for clinicians to check on it, right? And this is a big deal. This is a big, big deal. Okay. How many of you work out here? Okay, only few hands, huh? All right. So I'm sure you'll relate to this. How many of you do any diet here? Diet? Okay. All right. So if you are doing diet or if you're working out, right? You will you'll start with so much energy that you want to do this exactly the same thing for the rest of the life every day. Huh? Some hours in the morning, some hours in the afternoon, right. We start like that, and then what happens? And then within 1 week, you're like, oh, I'm happy, right? I'm happy. My parents are happy. My professor is happy. Why? What's the? Yeah, it's okay. Yeah, right. You and then the whole thing goes down, right? But if you have a group, if you have a group that can push you, right? That can help go further, right? Yes, you guys agree with that, right? But sometimes even if that group is thinking similarly, okay, my parents are happy, why? And there will be one friend. There will be that one friend. We always have that one friend, right? That is like reviewer two, basically, for our papers. Huh? That will be the killer. You're like, why so much stress? Yeah. I just want to share this with you. in our where I did BTech. Yeah. Um, so how many years is BTech? 4, right? So, but there were these very special superhuman people. They did that for 8 years. There was one person who did it for 15 years though. Yeah, so that was I've never seen anybody in my life like that. Yeah. So, but anyway, this one person who, so we all used to be so stressed out during exams. It's like, wow, the stress always was there. But this person who was doing his BTech for 8 years, he will come like he's never seen stress in his life. He will come as if he's like, I mean, I've seen it all, So, right? So if your group is full of such people, then the group also doesn't help, right? But, but, right? But if the group is good and you can push yourself, right? Then that helps, right? Um, so what we especially wanted to create, why is everybody coughing? What we especially wanted to create for these people is we wanted to provide survivor groups. So this is like Facebook for them, right? Like-minded people who want to push themselves to recover from it. Okay. So we wanted to provide something like that, like a community support for them. This is really, really important. You might see the technology and all that on the other side, but this is also really, really important, right? Because we will give the device. We'll give the device. We'll give, okay, so I have to share one other example. So I don't know if this is implemented in India yet, but in the US, some health insurance companies, especially the ones that are working with industries, okay, they gave free Fitbits. And so you have to wear them and they will monitor you. So they will count the number of steps. They will count the number of steps, and for certain number of steps, you get some perks. Your insurance, the payments are kept down and all that. The reason they're doing is long term, they don't have to pay your hospital bills when you're admitted with sugar, diabetes, hypertension, etc. Right? So they're trying to monitor. So if you're healthy, that will save money for the company, right? My friend, okay, there's always that one friend, right? He's super intelligent. He would tie that Fitbit to his dog. There was somebody who was in 10,000 steps. He will get 30, 40, 50,000 steps, right? So device compliance is device adherence. So this is a big problem, not only in addiction, in everywhere. This is a big. Let's say I give you a tablet. What's the guarantee that you will take it or not? Let's say I give you a device. What's the guarantee that you will wear it or not? Right? Right? So device adherence is a problem. That's why you need the community support as well for that reason. Okay? So there's a lot of things behind the screens that I'm not covering all the detail, but a device, for it to be success, there will be 100 reasons. Okay? All right, this is again a work in progress. We are, so again, in this case, in all the previous cases, we are working with clinicians. That is a very, very key part. Okay, when I was talking to Shiva, he was sharing with me that there's a lot of medical centers here that NIT started working. That's extremely important, right? Otherwise, you will think you will work for 4 years and you will develop a wheel. Then the medical center will tell you we already have a lot of these, right? Okay, all right. So we got really, really good accuracies with different algorithms. And so we have two types of studies that we did here is we combined both physiological and EEG. We used only physiological to see how the results will pan out. And then we used only brain signals to see how the results will pan out. And something else that we were monitoring is the time length. Okay. So how much time do you really need? Okay. How much signal, how many samples do you really need to estimate, to do proper estimates? So we found that at the minimum, you need about 4 seconds. Anything below that, we were not able to get any reliable data. So you need about 4 seconds is still short, right? 4 seconds of data we need. Yeah. How was that? It's always overlapping window. It will always be overlapping window when you do. Yeah. But 4 seconds of time. Yeah. What percentage? Oh, I think it was 250 or 500 milliseconds overlap window. Yeah, yeah. But that, yeah, that's a signal process. Save it for later. Yeah. Okay. All right. And then we're getting into more interesting parts of the applications. Um, so we are developing cyber human systems for mental health. So we are developing robots that can dance with you. Okay. Um, and the reason why we're doing this study is it's a very, very simple idea. Okay. Very simple idea. Let's say you're dancing. Okay. Anybody dances here? Any dance training? Yes. Yeah. What do you do? You, yeah. Western and somewhat Bharatanatyam. What is that? Somewhat Bharatanatyam. Okay. Okay. And anybody else? This side? Okay. Any dancers that side? Yeah, ma'am. What do you? Ah, I see. I see. Okay. Okay. Good. 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 Okay. All right. Okay. All right. So for this to understand, you don't have to be a dancer, but um, if you are under stress and if you're asked to dance, okay, your movements will not be coordinated. If you are under stress, right, your movements will not be coordinated. If you have no stress, your movements will be coordinated. This is a very, very simple idea that we're trying to test. If your movements are coordinated, we can measure those in synergies, right? Like we did hand synergies, you can do whole body synergies. Yeah, right? We did arm synergies, we did hand synergies, we could do whole body synergies. And we can measure coordination. Make sense? Yes? Okay. So we're trying to measure interlimb coordination, and we're trying to use that as a marker for stress. Okay. So um, and we're trying to see, we could use virtual partners, right? We could use virtual dance partners. That is a low cost way to do it, right? So you can put on head mounted displays. There will be a character and that dances and you dance with it, right? Yeah. Um, or you could have a physical robot like this, right? But why are we even talking about all this, right? So this is that disease called schizophrenia. Okay, how many of you know this? How many of you know anything about this disease? Yeah? Okay, no. All right, write that down. The spelling is on the board. Schizophrenia. Look it up. Okay, Google it. Yeah, the sleep badge. You are able to see the board. Yes. Okay. Right. Write it down. Write down the schizophrenia and look up. Yeah. Okay. Read about it. Read about it. Okay. So in schizophrenia, okay, in schizophrenia, there is something what they lack. It's called interactional synchrony. Okay. Let's say you and I are sitting at a table. Okay. Then we start working with each other, right? Right. We start moving things around. We start working. We start collaborating, or depending on what we're doing, we start competing, right? We work with each other. But in schizophrenia, they lack that ability. Okay. And this is called interactional synchrony. They lack that. Okay. So because they lack that, what they do is they withdraw. If they're sitting at a table with you, they step back because they think that they are being judged by you all the time. So even if that is a therapist, they think that they are being judged by you. Make sense? Understand? Okay. So if if we take away the person and we give him a robot, suddenly they have a device like their cell phone that they can call their own. This is my robot. This is my device, right? And they trust and they think that that is not judging them. So that is the partner that we're trying to give. A robot that can dance with them, but they can also relieve stress, but can also help improve interactional synchrony. Once they reach some level of confidence, then they'll be back into the society. But in order to train them, we need this type of mechanisms. Make sense? Yes? Everybody get it? How many of you are feeling sleepy? Okay, okay. Of course, you're not going to raise hands, right? Okay, because you're already feeling asleep. Okay, okay. So I'm going to show you some really cool videos. How many of you know Media Pipe? Yeah, Media Pipe. Okay, so this is Google's open source algorithm. Anybody can use it. You only need webcam. Okay, so we use that, and we are estimating the movements, right? And this is one of my colleagues who is trying to stress test it. Okay, um, so he's standing in front of the camera. He's moving, right? And we got his movements, and we're trying to map those movements to that avatar on the screen. Okay? You can totally do this on your computer using that media pipe algorithm. Okay? Write it down. Media pipe. Okay? Google's media pipe. Yeah? If you're already using, don't write. You know it. Okay? All right. Okay. And what is that environment, the VR? Does anybody know what is that environment, the VR environment? No? Okay. It is Unity, also free. Okay, you can download it and you can start using it. Okay, YouTube has so many tutorials, very easy to learn and use it. And that avatar also is like an open source. We didn't build that. Okay, we just use. Okay, all right. Okay, and so that gets me to this project Shivam. Okay, um, the reason I named this project Shivam is after Shiva, and Shiva is also, what is another name for Shiva? Who said that? Thank you, sir. Okay. Why did you say that? Why Shiva has so many names? Why did you particularly say Natarajan? Performs dance. Correct. Thank you. So we're trying to develop this system called synergy-based intuitive virtual and augmented therapy for mental health. Okay. So that's why we named this as Shivam. We did one of our first demonstrations last year in June. So on the dais, there were two dancers, right? One of them is wearing an EEG cap, and that EEG cap also has a couple of electrodes to measure EDA. And the other student is acting like a robot, basically. Okay, so we were trying to see how a person will interact with a robot. Okay, um, and so some pictures from it, and so in the first video, we are motion tracking and using those motions to put it into the avatars so they can do the dance as well, right? So this is that first part where they were just imitating each other, right? And this was the second part where we were capturing the emotions from the dancer who was wearing the EG cap. The other was basically acting like a robot. So in that video, there were 3 stages on how a person will interact with a robot. The first will be curiosity, and then and then towards the end will be happiness, and they work together. And during that time, we were trying to display the brain signals on the screen, and we're also trying to pick on some electrodes and show what is their body temperature, what is their galvanic skin response, etc. Okay. All right. So this is a new addition to our lab, and we will be replacing that human partner with a humanoid robot in the next performance we're going to do, and that is this guy. This is that unitary robot, and we are just getting started with him. But this is a biped robot that can actually do quite some moves. I don't know if you saw. Was it IIT Kharagpur or IIT Kanpur? I don't know. What is that? Goose Goose in Dhurandhar? You know the song that I'm talking about? No? Yes, yes, yeah. Fasla, right? What was it? Huh? You know that? Everybody knows that? No? Please write that down. Search karo. F-A, F-A, F-A-S-L-A. Dhurandhar. Okay? That's the song. And for that song, they made this unitary robot dance. You got, yeah, yeah. That's the clip. That's the IIT Kharagpur one. What's IIT Bombay? Okay, okay. Thank you. You can stop now. I say masti ho raha hai. Okay. So the next is to see if these dancing robots can help people with schizophrenia. That's where we're progressing with that. Okay. So that was application 7. In terms of future research, we're going to be focusing on the first thing again is where we started, motor control and assistive devices. We will still be using these synergy-based models, and now new things that I've added are human-robot collaboration and coordination. The second part is motor learning and rehab. We're using a lot of our methods in working with physical therapists, etc., in active clinics. One of the key elements that we want to measure there is transference of skills. Okay, when you train for a certain task, how does those skills transfer? And also, we're trying to use these models in human-robot collaboration because we will be seeing a lot of robots in physical therapy clinics as well. Okay, and towards the last one is cyber physical systems for mental health. We're trying to develop neurotechnologies for mental health. And one of the therapies that we're trying to use is dance movement therapy as well. Yeah. Okay. That's good to dance. Yeah. Once in a while. Yeah. Good to dance. Yes. All right. So that is the end of this talk. But I want to introduce some centers, my students who have done all this work to you. Okay. So the first one is our center. It's you can easily get to it with nsfbrain.org. This is an NSF, National Science Foundation funded brain center. Okay. You can easily get to it using nsfbrain.org. We are one of the sites in this center. Okay. And this is an IUCRC. What it means is an industry university cooperative research center. So my students are directly working with some of the neurotech companies, and the vision of this center, okay, the vision of this center, and you will immediately relate to these 2 things, the vision of this center, right? One is to get technologies from lab to people, okay? That is one of the foremost. We want to get these technologies to help people, okay? The second thing is training future workforce. That is the second. Okay, so we want to train our students directly working with these industries to see if they can get that real-time experience during their education itself. Okay, so these are the two primary visions of this center. One is getting the technologies from lab to market. Second is training the future workforce. Okay, so that is the vision of this center. We have a lot of programs where we have even mentored some of the high school students um, in this center. And there are 5 key areas that this center focuses on: cyber human systems that I'm leading, big data and AI that one of my colleagues is leading, machine learning and signal processing, neurostimulation and modulation, and virtual reality and augmented reality. These are the 5 themes that we chose from our site. Okay, there are, as you saw, there are other sites in other universities. They're focusing on different themes. Okay, and the good thing, like I said again, is that we partner directly with a lot of medical centers. Maryland Psychiatric Research Center, CIBIR is Center for Brain Imaging Research, Hopkins, Maryland Medical Center. So we are working with clinicians. This is another key part, okay? And industry collaborations. We're working with several industries. 30 plus companies are part of this center, okay? And so we work with them, okay? And so that they push us and we push them, okay? Then we get work done, right? Um, and here are some of the pictures from these brain events. And this was the last year, mid-year, around June, we hosted this event where you saw those 2 videos. They were from this event. And this is my lab. This is my lab. And we had a lot of leadership. We had a lot of support from the university to do this meeting. And we also had a lot of student interactions. That was also really key part of it. And in addition to our performances, there are also other very famous. She's a Grammy nominee and also a neurologist who plays piano. And she had her performance where she was wearing EEG. Audience, one person was wearing EEG, and he was seeing. And again, all these will make sense when we talk about neuroprosthetics. You will see that all these will make sense, okay? And of course, our performances as well. And this is the center national director, Contreras Vidal, who worked using EEG. And robot dance partners. If you Google robot dance partners, Vinjamuri, you will get a lot of these papers that were published. Okay, and last but not the least, over 3-4 sessions, right? I've been showing off, right? Showing off what we accomplished. That is all the work done by these students. Okay, some of these are PhD students, some are masters, undergraduate. Some of these are high school students, okay, that have contributed to this research. This is my lab, and this was the time when I had short hair. um, and we have a lot of collaborations with India. We got a lot of grants where NSF funded our centers, and technology innovation hubs funded Indian partners, and we had a lot of grants in exchange. And this is one slide. These are all undergraduate students. They're all in their second, third, or final year. These are all BTech students, okay? And they did some fantastic research. This particularly, this guy, he did hand exoskeleton control using EMG signals. And so I was sharing in the opening talk also, I shared this. All my degrees are in electrical engineering, okay? Any electrical engineers here? Nobody, is it? Oh, okay. All my degrees are in electrical engineering. BTech, master's, PhD, all my degrees are in electrical engineering. If I have to be trained in the type of research that I'm doing, very multidisciplinary, very clinically oriented research, I need my gurus. I need my mentors and collaborators that have actually taught me in this very interdisciplinary science, right? So I'm extremely grateful to my mentors, and some of them are here. My postdoctoral mentor, Doug Weber, is now in Carnegie Mellon University. Some of clinical partners, neurologists, and this is another big person from University of Pittsburgh Medical Center, Mike Boninger, and Pepe and Marco. These are my gurus who mentored me in where I am right now. Some of the collaborators. So of course I cannot do everything on my own. So these are my collaborators who have partnered in this center and helped me to manage this center. Okay, and with the so when I did my master's thesis, no, when I did my PhD, I said that I'm trying to model how brain controls hand and all that, and nobody even understood what I'm talking about. Okay, but in my postdoctoral years, in one of the studies, we put a circuit, a chip, in an individual with spinal cord injury. Okay, and we were all over the news. Okay, and then people started appreciating, "Acha, kuch to useful kar raha hai tu." Okay, you're doing something useful. Hello, sir. Thanks for coming. Um, so that was my my postdoctoral years, right? And then after that, very recently, when we started doing this human-robot interaction and dance, we could so easily connect to people. Okay, all right. So the future is going to be extremely interdisciplinary. Okay, with the AI, the future is going to be extremely interdisciplinary. The more interdisciplinary you are, the less replaceable you are. Okay, if you are a coder, you're replaced. If you are a pure mechanical engineer, you're replaced. Okay, so anything that is more and more interdisciplinary, that will take you farther and farther. Okay, anything that you do with clinical partners, that will take you farther and farther. Okay, so please pay attention to that. All right, and these are my other collaborators. This is the guy from Stanford I was talking about. Um, his name is Monroe Kennedy, and I cannot do this type of research without funding from agencies, right? So this is National Science Foundation, and this is United States India Science and Technology Foundation, and there are these other agencies and labs that supported my work. Um, and I cannot do this type of research without medical centers, right? And that's why we have University of Pittsburgh Medical Center, Hopkins, UMC, University of Maryland Medical Center that I work with. Okay. Um, Sometimes when you don't get grants, when your grants get rejected, and when you get an award, that also will keep you motivated to go for the grant next year. So I'm also thankful to all those awards that I got, because those also motivated me to push myself more. And so this is my lab. You can easily get to it by searching Vinjamuri Lab. Okay, just Google Vinjamuri Lab and you will get to this. All right, and we have some papers, publications, research themes posted on there. So please take a look. And that is my email. So just take a picture of that. So many people were asking me about my contact information. Take a picture. Please email me if you have any questions, if you have any feedback, new ideas. And if you, oh, sorry. Okay. And if you are on LinkedIn, please connect with me. I'm happy to stay in touch. Yeah, some of you already connected. I saw that some of you are already connected. Thank you for those who are connected. And if you haven't, please connect. All right, so that's 3:15. That's the end of this session. Okay. Um, Karthik is going to come in and give you more useful science. Okay. All right. Any questions? Or should we take a break? Take a break? Take a break, and 3:30 Karthik begins. Yes? Okay. If you have any questions, I'm here. Okay. Right. Thank you so much. Thank you. We'll continue tomorrow. We'll start with fundamentals. We'll start with prosthetics, and then we'll continue with neuroprosthetics. So that'll be 4, 5, 6 more modules. Okay. All right. I'll see you tomorrow. Thanks.